So this is the problem set for 1.3. 1 through 4, what you're doing there is something that shouldn't be too hard. You're just putting angle theta in standard position. So you've got that there, you've got your line there, and it wants angle theta in standard position. So we go over 5 down 12, and we draw that line. That's all they want for that. 2, we go over negative 12 and down 5, and then you're drawing a line there. So this line is what they're looking for B. This line is what they're looking for A, and then for 1, and then go ahead and do 3 and 4. 5 through 12. Find the values of the 6 trig functions for each angle in standard position. So again, you've got your xy axis. They want you to graph, like number 5 says, negative 3, positive 4. So we've got that point there. We draw a line. We draw a line down from the point they asked us to find. And I know this is negative 3. I know that's 4. And then I can find r by taking this squared plus this squared and taking the square root using the formula, that Pythagorean theorem there. So r is going to be 9 plus 16, so r is the square root of 25, so r is going to be 5. That doesn't look like a very good 5, does it? Okay, let's get rid of this, because we know it's 5. We just kind of use that as a worksheet, and that's 5. Now they're asking to find the trig functions. So you're going to do cosine of theta, because this is theta. And theta is going to be y over r, or 4 over 5. The ratio of the opposite over the hypotenuse. So that's cosine, then you're going to do the other 5 of them. So you do that 5 through 12. 13 through 16 are just some questions there for you to answer. When you get to number 17 through 24, suppose that the point xy is in the indicated quadrant. Decide whether the given ratio is positive or negative. Alright, so what we're doing here is we've got our xy axis. 17 says we're in quadrant 2. This is quadrant 2. And we have an x over r. So we're just going to draw any angle we want. Doesn't really matter as long as it's in that second quadrant. And we have our x, and our x is going to be negative in that quadrant, right? Because we had to go over negative. In order to get here, we had to go over negative, and we had to go up a positive y, and r is always negative. So they're saying, if we have x over r, is our answer going to be positive or negative? Our answer is going to be negative, because a negative over a positive is a negative. If we were to look at, let's just do one more here real quick. If we were to look at 24, it says quadrant 4. There's quadrant 4, and they're asking for any triangle. Again, we just draw one, and that's going to be negative y, that's going to be positive x, and that's going to be r. And they say if we have y over r, so y over r is going to be a negative answer. So all they're wanting to do is the answer positive or negative? So 25 to 30, let's go ahead and draw our xy axis. Let's look at number 26. 3x plus 5y equals 0, and they're giving us a restriction. They're saying x has to be greater than or equal to 0. So we can pick any number in the whole history of the universe for x as long as it's bigger than 0. So let's put in 3. So when x is 3, what is my y value going to be? So 9 plus 5y equals 0. 5y equals negative 9. Y equals negative 9 over 5. I don't like that. So what we're going to do is we're going to try a couple numbers so that when we put a number in for x, we get a y value that's actually a whole number instead of a fraction. So what I'm going to do is I'm going to set this equal to y. So I'm going to make this 5y equals negative 3x. Divide by 5, divide by 5. Okay, so that gives me 5 equals negative 3x over 5. So now it makes it a little bit easier to get a whole number here, because it's going to be easier for me to pick a number to put in here, times 3, divide by 5 to get a whole number. So for example, if I put a 5 in here, that would give me negative 15 over 5, which is negative 3. So that would work for me. And that gives me, so y equals negative 3 times 5 over 5 is negative 15 over 5. So therefore y is negative 3. So when x is 5, y is negative 3. And that's what I want here. So when x is 5, y is negative 3. So then what I have is this. I'm going to graph that. So over 5, 1, 2, 3, 4, 5, down 3. And then I make a triangle. So I know that's negative 3, I know that's 5, and then I have to find my r value. I've always got to find my hypotenuse then. So I know from what we did before that r equals the square root of x squared plus y squared. So r equals the square root of 3 squared plus 25, which means r equals 9 plus 25 is 34. So r equals the square root of 34. Alright, so what am I going to do with that? Well, I'm going to find my 6 trig functions based on that reality. So let's get rid of some of this since I don't need all of that graph in there. And some of this won't disappear. Okay, that will. Alright, so now I just have to find the sine of theta. Sine of theta is y over r, and y is negative 3, r is the square root of 34. Getting rid of the square root, I multiply top and bottom by the square root of 34, and I get negative 3 square root of 34 over 34 for my sine of theta. And then I do that for the next 5. So 33 to 42, use trig function values of quadrantal angles given in the section to evaluate each expression. So when we have something like, let's start out with 34. We have tangent. I am not going to use that color. Tangent of 0 degrees minus 6 sine of 90 degrees. So you take your calculator and you plug in tangent of 0, or you look at the table on page 24 and find the tangent of 0, and it's 0 minus 6. What is the sine of 90? You look at your table, the sine of 90 is 1. So we have 0 minus 6 times 1 equals negative 6. This here, if you have a number in front of a trig function here, it just means whatever your sine of 90 or sine of 30 or whatever you're looking for here, you multiply by 6. That's all that means. If I have something like number 38, I have 2 secant of 0 degrees plus 4 cotangent squared of 90 degrees plus cosine of 360 degrees. If you look at that table on page 24, you'll find out that the secant of 0 is 1. 4 times the cotangent squared of 90. Cotangent squared means you take the cotangent of 90 and square it. Okay, they just put the squared sign there, but it's cotangent of 90, and then you square it, plus the cosine of 360. Cosine, I'm looking at the table here, cosine of 360 is 1. So 2 plus 0 plus 1 equals 3. So the answer then for number, what did I just do? Is that 38? Yeah, number 38 is the number 3. So it looks a lot harder than what it is, but it's really not too bad. All right, so 43 to 46. If n is an integer, n times 180 represents an integer multiplier, or multiple of 180. Okay, so they give you a whole bunch of stuff there, and they just want you to decide whether each expression is equal to 0, 1, -1, or is undefined. Now notice, when you look at quadrantal angles, 90, 180, 270, and 360, the only options you have for an answer there when you take the cosine of 90, cosine of 180, cosine of 270, cosine of 360, your only options for an answer are 0, 1, -1, or it doesn't exist. It's undefined. That's all the option that you have there. So what I want you to do for 43 to 46, if there's any problems assigned there, just skip those, but I did want to at least go over your 4 different options for answers for quadrantal angles. So when it says provide conjectures in exercises 47 to 50, a conjecture is an educated guess. So what would you think would be true if such and such happened? You know, what kind of guess could you have of what would happen maybe in the future or with the next angle or something like that? So other than that is, I think you'll be okay with the rest of the problems with 1.3.